Hello, all my dear students. I'm your mentor Amit Ajmani, and I welcome you all to Sri Jendra Rank Zone classes. Students, in today's class, we'll be starting up a fresh chapter, that is pressure and Archimedes principle. So let us see first of all what exactly is meant by pressure. Pressure is the force acting perpendicularly on a unit area of the object, right? And if we want to calculate the pressure, it is calculated by the formula pressure is equal to force upon area. Now the SI unit for measuring force, we know that it is Newton expressed as capital N, and the SI unit for measuring area is square meter or meter square. So the SI unit of measuring pressure is Newton per square meter, which can be written as N slash M square or Nm minus 2, right? Which is also called Pascal, which is represented as capital P and small a. So we can say that 1 Pascal, that is 1 Pa, is equal to 1 Newton per square meter or 1 N per M square. Now in the formula of pressure, we can see that there are two things that we have used. One is the force and another is the area. So if we need to know what are the various factors on which the pressure depends. So obviously there will be these two factors only. One is the force and another is the area. And how pressure depends on these? Pressure is directly proportional to the force acting on the body. That means more is the force, more will be the pressure exerted. And pressure is inversely proportional to the area of contact. Means if the area of contact is less, that means more force is acting on that lesser area, hence increasing the pressure. And if the area of contact is more, in that case the pressure exerted on that large area will be reduced, it will be decreased, right? One more thing that we need to relate is the force acting on a body perpendicular to its surface is also known as thrust. So we can also define pressure as thrust per unit area is called pressure. Instead of writing force, we can write thrust also. So the pressure is equal to thrust upon area, and the SI unit of thrust is also Newton. Now we have seen that pressure is inversely proportional to area. This particular relation is used in many day-to-day observations. So let us try to explain some everyday observations on the basis of pressure. We have seen that the school bags have wide straps. Now why is it so? The reason is that pressure is inversely proportional to area. So if we increase the area by providing these wide straps, the pressure will be reduced. So if there are wide straps on the school bags, then the force acting on the shoulders of the children, that is reduced. Clear? Second observation is a sharp knife cuts better than a blunt knife. Again, because being sharp means the area of contact is reduced. And if the area is reduced, pressure being inversely proportional to area, that is why the pressure is going to increase, and that is why a sharp knife cuts better than a blunt knife. We have seen the tip of a needle is very sharp. Why is it so? Or a nail has a pointed tip just like a needle. Why is it so? Because by making the tip sharp or pointed, we are actually decreasing the area. So when force is applied on them, whether in the case of needle it is through hand or in the case of nail it is through hammer, so the area, since the area is decreased by making them sharp and pointed, therefore more pressure will be exerted by them, right? So these all the explanations are based on simple one relation, that pressure is inversely proportional to area of contact. There are so many other observations based on the same explanation. Let us see. The pressure of on ground is more when a man is walking than when he is standing. Now, what could be the possible reason? Very simple to understand, that when a man is standing, he is standing on both his feet. But when he is walking, at a time, he is only putting all his weight on one foot. So if we relate the area of contact while walking and standing, it is one foot or both the feet. So while walking, the area is less, and since the area is less, the pressure will be obviously more. Reason again the same, that pressure is inversely proportional to area. Exactly the same explanation can be given in the next observation, that the depression is much more when a man stands on the cushion than when he lies down on it. Now, when he is lying down and when he is standing, the only difference is the area of contact. The area of contact while standing will be less as compared to the area of contact while he is lying down. That is why less area will exert more pressure, and that more pressure is going to cause more depression in the cushion. We have seen the tractors. We have seen the tractors, the hind tires, the behind two tires are very broad. Why is it so? Because the tractors normally is used in the fields where the soil is quite muddy or it is soft soil. So the tractors have broad tires, because being broad, the area is increased, due to which the pressure they exert on the ground or on the soil is less. Had it not been the case, then the wheels of tractor would have got inserted in the mud, making it very difficult to work. So again, the concept is increasing the area leads to decreasing the pressure. We have seen a wide steel belt is provided over the wheels of army tanks. Now these tanks are very heavy. So if these tanks are moving on wheels, they are going to exert so much of pressure, because in case of wheels, the area of contact will be less. So the pressure will be more. In order to decrease the pressure, this wide steel belt is provided, which is very wide, because of which the whole of the pressure is disseminated in that particular area. This wide steel belt provides the large area and hence decrease the pressure. Similarly, we have seen that the wooden sleepers or the concrete sleepers are kept below the railway line. It is also because of the same reason the train carrying so many passengers, fully made up of iron, is so heavy. So when this train moves on the railway line, it exerts so much of pressure. That pressure the railway line will not be able to tolerate, and the railway line is going to go deep into the ground. But it is just because of these wide wooden sleepers that this pressure is reduced, because they provide more area. Same reason that the snowshoes have large flat soles. They are never pointed. Why? Because snow is so soft. So if we are going to wear the pointed shoes, they will reduce the area and increase the pressure, due to which our feet will get inserted into the snow. So that is why they are always having large flat soles, to increase the area and hence to decrease the pressure. Another observation is, it is easier to walk on soft sand if we have flat shoes rather than shoes with sharp heels or pencil heels. Again, why? Because if the heels are sharp, the area will be so less that the pressure is going to increase many folds. Due to the same reason as we have seen in the case of snowshoes, soft sand is because soft, so it will be easier if we'll be walking with flat shoes, hence increasing the area and as a result decreasing the pressure. Got it? The next observation is, the foundations of buildings and dams are laid on a large area of ground. Why so? Why we are increasing the area? Just in order to reduce the pressure which will be exerted by the building or the dam that will be built on this foundation. So these are a few observations, all based on one simple fact, that pressure is inversely proportional to area. On increasing the area, pressure will be decreased, and on decreasing the area, pressure will be increased. Got it? Now let's come to atmospheric pressure. What exactly is atmospheric pressure? As the name suggests, the pressure exerted by the atmosphere is called atmospheric pressure. The value of this atmospheric pressure when we measure it on Earth at sea level is approximately 1.013 in 10 to the power 5 Newton meter square. Right? Quite important. Aneroid barometer is an instrument, is an equipment which is used to measure the atmospheric pressure and height of a place. Now, when we are talking about the pressure exerted by a liquid, it increases with depth and it acts in all directions. We'll study this particular point in detail later in this same chapter only. Right? So this is about atmospheric pressure. Let's talk about pressure in liquids. If we try to relate the pressure in a liquid at a depth h below the surface of a liquid of density rho, then pressure P is given by the formula P is equal to rho into G into H, where P is the pressure exerted by the liquid, rho is the density of the liquid, G is the acceleration due to gravity, whose value we know is 9.8 meter per second square, and H is the height or the depth below the surface of a liquid. This formula you need to remember because its application comes in the examination. So how we calculate the pressure in liquids? The formula is P is equal to rho into G into H. In this, G we already know the values of rho, that is the density of the liquid, and the value of H, that is the depth. They will be given to us in the question. We can calculate the pressure. Next, and a very important term, is buoyancy. Now what exactly is buoyancy? Please try to understand, because this is very important from exams point of view. The tendency of any liquid to exert an upward force on an object placed in it is called buoyancy. Every liquid exerts an upward force on any object which is put in that liquid. This tendency of the liquids is called buoyancy, and this upward force which is exerted by the liquids, this force is called buoyant force. It is also known as upthrust, right? If it is in the upward direction, it is upthrust, or if it is in the downward direction perpendicularly, it is downthrust. So liquids, they exert upthrust. Clear? Now this buoyant force or the pressure exerted by liquid increases with depth. The deeper you go inside a liquid, more pressure, more buoyant force, more upthrust will be exerted on the object, and this pressure acts in all directions, even upwards, right? Let us study a bit more about this buoyant force. There are various factors which affect the buoyant force. What are these? Number one, and the very important factor, is volume of the solid object immersed in the liquid. The buoyant force is directly proportional to the volume. That means as the volume of solid object immersed inside the liquid increases, the upward buoyant force also increases. Hence, they are directly proportional. Now, when an object is completely immersed in the liquid, then this buoyant force becomes maximum, and after that it remains constant. Quite important thing is the magnitude of buoyant force which is acting on any solid object does not depend on the nature of the solid object. The object is made up of plastic, or it is made up of wood, or it is made up of cork, or it is made up of leather, or it is made up of iron. It doesn't make any difference on the amount of buoyant force, right? The buoyant force depends only on its volume. What is the volume of the solid object? Depending upon that, the amount of buoyant force will act on it. This is very important points. Please try to remember. Taking an example, if two balls made of different metals which are having different weights and different densities, but if they have got equal volumes, and if both these balls are fully immersed in a liquid, then since they have got equal volumes, they will experience an equal upward buoyant force. And later in Archimedes principle, we will understand this concept in detail, which is written in the brackets, that they will undergo an equal loss in weight. What exactly is meant by this statement? You need to wait for another 10-15 minutes, then you will be able to relate this particular sentence also. Right now, need to relate this thing, that even though these two balls were made up of different metals. These metals were having different weights, but it does not cause any change in the amount of buoyant force acting on them just because they have got equal volumes. Got it? So if the volume is same, the amount of buoyant force exerted by a liquid will remain same, right? And there will be an equal loss in weight. The reason behind that is because both the balls will displace equal weight of the liquid as they have got equal volumes. So this is the first factor affecting buoyant force, that is the volume. Now the second important factor is the density of the liquid in which the object is immersed. If the liquid is having higher density, then it is going to exert more upward buoyant force on an object as compared to some other liquid which has got lower density. That means as the density of liquid increases, the buoyant force exerted by that liquid also increases. Taking an example, if we take sea water, now sea water has higher density as compared to the fresh water. Why is it so? We all know that sea water contains various salts in it, because of which its density increases. And since sea water has more density, therefore this sea water will exert more buoyant force on the object which is immersed in it as compared to the fresh water. So these are the two factors. One is the volume of the object and second is the density of the object. These are the two factors on which the buoyant force exerted by any liquid depends. One important thing that we also concluded is that the buoyant force does not depend upon the nature of the material of the substance. Right? Clear? Now, let us come to next very important topic, and that is Archimedes principle. Now, according to Archimedes principle, when an object is wholly or partially immersed in a liquid, we are actually just immersing a particular solid object in a liquid. And when an object is immersed, it experiences a buoyant force or an upthrust that we have already studied above. Important thing is that this buoyant force is equal to the weight of liquid displaced by the object. So we can say that the buoyant force or the upthrust acting on an object is equal to the weight of liquid displaced by the object. This is what said the Archimedes principle. Now this Archimedes principle has various applications. Let us try to relate, they are all important. This Archimedes principle is used in determining the relative density of any substance. The second application is in hydrometers. These are the devices which are used for determining the density of liquids, and these hydrometers are based on this Archimedes principle only. The next are the lactometers, which are used for determining the purity of milk. They are also based on Archimedes principle, and Archimedes principle is used in designing the ships and the submarines. So these are a few applications of the Archimedes principle, right? Now we have observed that when we put a substance in a liquid, certain substances or objects, they float in the liquid while some other sink in the liquid. Why is it so? Let us try to relate the reasons for it. Now when an object is put in a liquid, there are two forces which are acting on it. The first force is the weight of the object which is acting downwards, which tends to pull down the object because of the acceleration due to gravity which pulls everything towards it. And second is the buoyant force or the upthrust which is acting upwards, and this upthrust tends to push up the object. Now we have got three options. What are these three options? We are talking about two forces. One is the buoyant force and one is the weight of this object. The first case is that if the buoyant force or the upthrust exerted by the liquid is less than the weight of the object, then in that case the object will sink in the liquid. Second option is that if the buoyant force or the upthrust exerted by the liquid is equal to the weight of the object, then the object will float in the liquid. And the third case is that if the buoyant force or the upthrust which is exerted by the liquid on that object is more than that of the weight of the body, then this object will rise in the liquid and then float, right? So this is why certain objects sink in a liquid whereas certain objects float over it. Let us try to understand the principle of flotation. According to the principle of flotation, an object will float in a liquid if the weight of object is equal to the weight of the liquid displaced by it. That means in order to float, the weight of the object should be equal to the weight of liquid displaced by it. This is the principle of flotation. Now let us try to relate the density of floating objects. An object will float in a liquid if its density or the average density is less than that of the liquid. If the density of an object is less than that of the liquid, then this object is going to float in such a way that a portion of the object is inside the liquid, or we can say it is submerged in the liquid, and the remaining portion is above the surface of liquid. Second scenario is that an object will also float in a liquid if its density is equal to that of the liquid. Now in this case, the object is going to float in the liquid, but the difference is that it is going to float in such a way that all of it remains submerged in water. No part of it remains above the surface of water. And the third option is that if the density of the object is more than that of the liquid, then the object will sink in the liquid, right? So this is why and how the objects float or sink depending upon their densities as compared to their weights. Now we have discussed about the density here. We need to relate in detail what density actually is. The density of a substance is defined as mass of the substance per unit volume. So we can say that density is mass of the substance divided by the volume of the substance. Or we can write density is equal to mass upon volume or mass per unit volume. We know that the SI unit of mass is kilogram and the SI unit of volume is cubic meter or meter cube. So the SI unit of density becomes kilogram per cubic meter, which is written as kg per m cube or kg m minus 3. Now, important thing you need to relate is that the density of water is 1000 kilogram per meter cube. What exactly is meant by this statement? By saying that the density of water is 1000 kilometer per meter cube, we mean that the mass of 1 cubic meter volume of water is 1000 kilograms. Now this is when we are using in the SI units. But if we express the density in smaller units, this is done in a unit gram per cubic centimeter, which is written as G per cm cube or GCM minus 3. Importantly, the density of any substance under certain specified conditions is always the same. So we can also say that density of a substance is one of its characteristic properties. Got it? So this is about density of a substance, which is equal to mass per unit volume, and its SI unit is kilogram per meter cube, or smaller unit is gram per centimeter cube. Right? Now, as we have discussed above, if the density of a substance is more than the density of water, this means that the substance is heavier than water, and hence if this substance is put in water, it is going to sink. But if we take the other scenario, that if the density of a substance is less than the density of water, the conclusion drawn is that the substance will be lighter than water, and hence it is going to float in water. Right? Now, what is the density of a substance as compared to the density of water? For this relation, we calculate the relative density of any substance. Now, what exactly is meant by relative density? Let us try to understand. The relative density of a substance is the ratio of its density to that of the density of water. So we can say that relative density of a substance is equal to the density of the substance divided by the density of water. Now above we have just studied that what is the formula for density? Density is calculated by the formula mass per unit volume. So we can simply write mass per volume in this above equation number, let us say 1. So now the formula becomes relative density of a substance is equal to mass of the substance divided by the volume of the substance multiply by volume of water divided by mass of water. Now if the volume of the substance and volume of the water are same, then relative density can be expressed as mass of the substance divided by mass of water. But the condition applied is that their volume should remain fixed. So we can say that the relative density of a substance is the ratio of the mass of any volume of the substance to the mass of equal volume of water. The volume of substance and the volume of water needs to be equal so that they can be cancelled out. Only then we can relate the above equation in these sentences or words that the relative density of a substance is the ratio of the mass of the substance of any volume to the mass of water of an equal volume of water. Got it? Now the important conclusions that we need to draw from these formulas is as the relative density is the ratio of two similar quantities, that is masses, it has no units. It is unitless. Thus, whenever we are expressing relative density, we will be expressing it in the form of a pure number. Another important thing is the relative density of a substance expresses the heaviness or the density of the substance in comparison to water. Let us try to understand with the help of an example. For example, if we say that the relative density of iron is 7.8, we actually mean that iron is 7.8 times as heavy as an equal volume of water. Got it? So, the relative density of water is 1. Now, if the relative density of any substance is more than 1, it means that that substance will be heavier than that of water, and therefore if this heavier substance or object is put in water, being heavier, having more density, it is going to sink in water. So any substance having density or relative density, I should say, any substance having relative density more than 1 means that it is heavier than water. And since it is heavier than water, if it is placed in water, it is going to sink. On the other hand, if the relative density of a substance is less than 1, what does it mean? It means that this substance or this object is lighter than water. And now when this substance is put in water, being lighter, having less relative density, having less density than water, it will float in water. Got it? These are very important concepts that you need to relate because you will be finding questions based on these in your examination. So this is all about pressure and Archimedes principle. Before ending this particular session, let us try to summarize the chapter once again. What all did we learn in this chapter? Try to relate it. We studied about pressure first. What is pressure? Pressure is force per unit area. SI unit, Newton per meter square, or it is expressed in terms of Pascal. The SI unit of pressure is Pascal, and 1 Pascal is equal to 1 Newton per square meter. Next, there are two factors on which pressure depends because pressure is equal to force upon area. So it depends on these two factors. First is force, second is area. How? Pressure is directly proportional to the force and pressure is inversely proportional to the area of contact. And a force which is perpendicular is called thrust. So pressure can also be defined as thrust upon area. Now based on the fact that pressure is inversely proportional to area, we have got many reasoning questions. School bags have wider straps. Sharp knives cut better than the blunt knives. Tips of needle is sharp. Nail has a pointed tip. Then we studied about the pressure on ground more when a man is walking as compared to when he is standing, or the depression is much more when a man stands on a cushion than when he lies down. Tractors having broad tires providing wide steel belt in case of army tanks, wooden or concrete slippers kept below the railway line, snowshoes having large flat soles, easier to walk on soft sand with flat shoes as compared to the sharp heels or pencil heel shoes, foundations of buildings and dams laid on larger area of ground. All these explanations are explained on just one simple logic that pressure is directly proportional to area. If you increase the area, pressure will be decreased and vice versa. If you decrease the area, pressure will increase. So if you want to increase the pressure, decrease the area of contact. And if you want to decrease the pressure, increase the area of contact. Next, we talked about atmospheric pressure and its value is 1.013 into 10 to the power 5 Newton per meter square. Important thing, in order to measure atmospheric pressure and the height of a place, aneroid barometers are used. Next again important point, the pressure exerted by liquid increases with depth and it acts in all the directions. This formula will be used in practical based numericals that the pressure exerted by the liquids is equal to rho into G into H. P is the pressure, rho is the density, G is the acceleration due to gravity and H is the height or the depth. Then we studied very importantly about buoyancy. It is the tendency of any liquid to exert an upward force on the object placed in it. This tendency is called buoyancy and this force which is exerted is called buoyant force or the upthrust. This pressure, this force, this upthrust increases with depth and it acts in all directions. There are two factors which affect the buoyant force, ultra important. First is the volume of the solid and second is the density of the liquid. Buoyant force is directly proportional to both these factors. If the volume of the solid increases, the buoyant force will also increase. If the density of the liquid increases, the buoyant force again that is going to increase. So these two things you need to relate. And third important thing is that the buoyant force does not depend on the nature of the solid object. It only depends on the volume, which means that if two objects of same volume, even though different weights, different material, different densities, if they have got the same volume, then they are going to experience the same amount of upthrust, the same amount of buoyant force from that liquid. Got it? Another important thing that we need to relate is that the sea water exerts more buoyant force as compared to fresh water, because seawater contains salts dissolved in it, because of which its density is going to increase. Similarly, the mercury metal, which is liquid, it is much more denser as compared to seawater. It is going to exert more buoyant force. So if you place some iron nails in water, even if it is sea water, they are going to sink, but they will kept afloat in case of mercury, because of such a large amount of buoyant force acting, because of its very high density. Next, we studied about Archimedes principle, which states that when an object is wholly or partially immersed in a liquid, it experiences a buoyant force, and this buoyant force is equal to the weight of the liquid displaced by that object. Got it? This is the Archimedes principle, which is applied in various ways in the hydrometers, determining the density of liquid, in the lactometers, determining the purity of milk, or in designing ships and submarines. In order to determine the relative density of a substance, Archimedes principle is used in all such things. Next, the principle of flotation that we studied. These three cases are quite important. Number one, if the buoyant force is less than the weight of the object. The buoyant force is less than the weight. In that case, weight is more, with which the object is pulled down. So that is why it is going to sink. If the buoyant force and the weight are equal to each other, then in that case, the object will float in the liquid. And if the buoyant force is greater than the weight, now the object will rise in the liquid and then float. And these conditions give rise to the principle of flotation. We have seen that an iron nail sinks into water, but so large ships, they keep floating. Why is it so? Because of this principle of flotation, which states that an object is going to float in a liquid if the weight of the object is equal to the weight of liquid displaced by it. Clear? This is the principle of flotation. And this flotation principle is applicable based on the densities. Right? If the density is greater than that of the density of the liquid, then in that case, since its density is more, it will be heavier, it is going to sink, it is going to be submerged. But if the density is equal to or it is less than the density of the liquid, then it is going to float. Clear? We discussed in detail about the density, which is simply mass per unit volume. Need to relate the SI unit, kilogram per meter cube, and the lower unit, that is centimeter gram per centimeter cube. The density of water in SI unit is 1000 kilogram per meter cube, and in lower unit it is 1 gram per centimeter cube. Right? This density is a characteristic property of any substance. Why? Because under normal specified conditions, the density of the substance always remains the same. Right? Quite important, we talked about the relative density. The relative density is the density of a substance in ratio to that of the density of water. Or we also can define relative density as the ratio of the mass of any volume of the substance to that of the mass of equal volume of water. Another very important thing, this you normally get in exams, that the SI unit of relative density is nothing. It has got no units. It is unitless and it is always expressed in a pure number. And this relative density expresses the heaviness of the substance with respect to water. Right? If the relative density of a substance is greater than 1, that means it is heavier as compared to water, and therefore if it is placed in water, it is going to sink. If the relative density is less than 1, in that case it is lighter than water, and that is the reason why it will keep floating on the surface of water. So this is the chapter pressure and Archimedes principle all about. I hope that you must have understood quite a simple and a very small chapter, but there are lot many things to relate, to learn, and to take care of while giving answers. So firstly, I want all of you to just go through the chapter, learn the relevant and all the important concepts and important points. Then in the next class, we will discuss the various questions based on this chapter, which we have already seen in the past few years. Clear to all? So we'll meet you in the next class with the question answers of pressure and Archimedes principle. Try to prepare well so that you can also participate in the next class by way of giving answers. Right guys? So time to leave now. We'll meet you in the next class. Till then, study hard and take care of yourself. Have a great day guys.